Hi everyone, welcome to Maker's Machining. This is Tim. We're going to have a little episode here today on a indexer, dividing head, rotary table, whatever you want to call it. I've got a piece set up in the dividing head here. That's a piece that we have to reverse engineer or measure it so we can make another part like it, or multiple parts, and make a print so we've got a record of it. So what we're going to do here, I've got a couple of bolts in here. You can kind of see these are some holes that are counterbored for springs that are going to fit in there. There's some threaded holes there. I'm putting in a shoulder bolt that's got 3/8 threads and a 1/2 inch body. So they screw down in there, and what I'm going to do is measure across these bolts here, and I happen to know that if we measure across here, it's exactly 6 inches across. Okay, I don't know if you can see the reading on the caliper there, but it's exactly 6 inches from outside to outside. So since this is a 1/2 inch diameter shoulder bolt, we take off half of each, so our centers of our bolt circle is 5.5 inches, 5.500. Not 5.5 the fraction, but 5.500. So what I've done, I've put these two shoulder bolts in here, or stripper bolts, they're called either one, and I've put a straight edge, a parallel along there. And I'm going to show you that we've got this thing in here dead straight. You can see the indicator needle is not moving. I'm going back and forth, and I'm going to move it in and out. You can see the needle is moving. I'll go to another spot there. We'll go back and forth. It's nice and straight. So we're going to go and get back on the center of that. So we've proven out that our two stripper bolts are straight in line. So I'm going to go back now. I'm going to take this off of here. Take that parallel off of there. And I've already gotten the center of the part picked up on the control on the machine. So I'm going to go back to 0, 0. We'll throw an indicator in the hole there. Oops, wrong way. We'll get it right to our 0 point within 1/1000th of an inch, within a 1/2 thousandth. I'm going to put the indicator down in the hole here. I want to get the needle to touch that, just so it moves the needle a little bit. So you can see if I push a little pressure either way, it's right where it's supposed to be. I'm going to spin this around, and you can see that the needle is not moving. So I've already preset this at 0. Yeah, it's moved a hair. Maybe I'm off that 1/2,000. Let me go back here. There we are. Okay, so now we've got 0 run out in the bore, so we know where we're at. I can reset my zeros on the readout there if I want. So we've got our part set at 0. I'm going to reset the 0 here. X0 set, Y0 set. So we know the spindle of our machine is dead center in the with the part. And I'm also going to move over now to the, let me get this out of here. I'm going to move over to the edge here. It's important when you use an indexer or dividing head that you have your indexer sitting square on the table of the machine. So I'm going to bring this guy down here, and we're going to come over and touch the needle over on the base. Are we moving the needle there? No, not there yet.
It's moving.
Okay, there we go. You can see the needle's moved. So I'm going to run it across here. I've already got this set dead straight and square with the table movement. So we've got that covered. So now we know where we're at with the readings on our machine and that our vise is set. So now if we need to measure what we've got here, sometimes when you have these bolt patterns here, the bolt pattern may not be the same. So you have to measure to see if all the holes are the same exact dimension. Here we're at 1/742. If I was able to get in here, this is 1/744, 42. These are all the same. So if you're checking something to see what the dimension is, and you don't know what the diameter of the bolt circle is, you measure between all the holes. Make sure all 6 readings are the same. That way you know that there's not one that's off center, because every so often people make a bolt circle and they'll put one of the holes off 10 degrees or something. That way that piece can only bolt in place one way. In case there's an oil line going to match up with something, it'll always go in the right place. So we've got this set so it's straight. We've checked our numbers out here so we know that they're all equally spaced. And we're going to take this out of here now. So what we're going to do, we're going to get this back over at 0. We had our 0 reading before. Let's get this back to 0. I could probably do this with a click of a button if I had the program going in here. But we measured all these positions here previously, and now we're going to go, and if we were to go with our indicator again, this is exactly 5.5 inches between centers. So what's half of 5.5 inches? It's 2 3/4. So we're going to move over 2.750. 2.750. We've got a reading set there. We could tell the machine to go over 2.750 as well if we wanted to, if we have a CNC control on this. All of you may not have a CNC machine to do this with, so if you're doing the manual machines without a CNC control, just a digital readout, you can move over and pick up your hole, and this spindle then will be dead center in that hole. So you can kind of see where that's at. Now, the key thing with an indexer, or a dividing head in this case, or a rotary table, is you've got a bunch of readings on the dividing head that give you the radial dimensions around there. It's all the way around 360 degrees, and then by turning this handle here, every rotation of this handle will give you 4 degrees movement. I happen to be set right now at 3 degrees at 0, and if I make one full revolution, it'll go 4 degrees. Let's just do that once. You'll see it move to 124. I'm going to go all the way around to 3 again. So I'm getting this set over here at 3, right on 0. This is kind of an awkward position to show you this. I'm showing you what the dividing head looks like with the 0 reading there, but we've gone exactly 4 degrees. Says 124 right there. It was on 120 before. And so these lines on here, we've got the little 0 reading there, and each of these big lines, there's 0, 1, 2, and 3, and then 0 would be 4 again. We've got all the lines in between give you the minutes, and you can even go by these other smaller lines here. If these lines line up with some of these lines, then you can go to seconds. So there's 360 degrees in a circle. Each degree is 60 minutes, and each degree is broken down into seconds. So you can really get an accurate rotation to go around to get an angle. So we've moved 4 degrees. You can see our hole lined up pretty good before, but now it's definitely off center. So we couldn't make that cut because we're in the wrong spot. So we've got our 4 degrees here that we've moved. We're going to take this and go back to 120. We'll bring it up to 0 there, or bring it up to 120, and bring our 3 back to position over here. Okay, so we've got back to 120 degrees where we were before. So the indexer can give you readings and accuracy of movement to within a degree with minutes and seconds. So you can do exact readings when you are either maybe indicating this hole, or tapping and drilling the holes, counterboring them, measuring, whatever. You can get your readings, and then you can get set to where you're supposed to be with your cuts that you're making to make the new part. But they're very versatile, these indexers. I've had this one for quite a few years. It's heavy duty. It really works good. There's another way to use this also. This is, like I said, like a rotary table because it's doing a flat surface. You can see it's got a lathe chuck on there. They also have what you can put on there is a faceplate, maybe, just like in the lathe. There'd be a faceplate that you would have to bolt an unusual shaped part on there. But then, the next thing that we're going to do, we had talked about cutting a spline in a shaft some time ago, and what we can do is take this whole thing and stand it up at 90 degrees and use the chuck in the horizontal position. So hopefully we can get this thing posted here, and I'll stand this thing up, and maybe we'll do another quick video here yet today, so you can see both means of operating this. And I'm not going to take this part out of there because we know that when we're at 120 degrees with the 3 over there, that we've got our hole location just right. So if we stand this up, let's say we've got to put some set screws in the side here, we can get those set screws exactly where they want to be if we want to put, you know, a set screw in there to lock this stripper bolt in place when it's used. So we'll sign off on this one for right now. A little explanation on how an indexer works, or a dividing head, so we'll take a look at that. There's other dividing heads out there beside this one. Like I say, I've had this one for a long time. In a lot of cases, and probably the way this part was made was on a CNC mill, where you can tell it, okay, I want to do a bolt circle with 6 bolts in it, and it'll go around and do the first part is the center drill, then you go around. But you can see here, I got it in the wrong spot here. If you drill a hole through there, you'd be drilling into the jaw. So you got to take that into consideration too. Maybe I should have had this set the other way. We're just measuring this piece for right now, but that's something to think about too. You don't want to drill a hole in your tooling. So if, you know, right now we've got these two across from each other. If we would turn this thing this way, 90 degrees, we wouldn't hit any of those holes most likely. Anyhow, you might have to finish it up in the drill press afterwards too, just when you're drilling your hole. But we'll talk a little bit more here about this as I stand this thing up and show you how it's used this way. Okay, we're done for this one. We'll talk to you soon. So long.